All right, guys, we are doing, this is for Thursday and Friday, January 6th, no, January 7th and 8th. Sorry, still not there. So hopefully the videos are working well for class while I'm gone. If you are also gone, I've been getting lots of emails with students also not going to be there this week. So hopefully this is helpful for everybody. I wanted to do a quick reminder of Canvas things and some other class things. Remember, stay off your phones, guys. Do what you're supposed to be doing in class. You have plenty of time to get these assignments done in class, so you don't have homework. If you do not get them done in class, they become homework for you. Because you don't have remote school anymore, there's no hybrid, you're in class every day. These assignments are expected to be finished by the next class period, okay? Because when we start having quizzes, you will take them in class, whether you're there, whether you've been there or not. So you need to stay caught up on Canvas because everything is there ahead of time. Okay, I'm gonna talk a little bit more here about Canvas just real quick. Okay, again, if you forget how to make everything as a PDF to turn it in, here it is. The January 5th through 13th, so that's yesterday that was this Tuesday through next Wednesday. As you see, the videos will come up. Okay, I didn't point out so much. So this was Tuesday and Wednesday's lesson. This is the full one that you watched if you were in class. If you just need quick refreshers over certain segments, I have them broken out into just those parts there. If you're at home and don't have the notes packet, you can click on Chapter 5 notes packet and it gives you the Chapter 5 opener notes. I don't know if you can see those or not when it comes up, okay? So you can print those off at home. That's what that link right there is. Also, this one down here is the link to the practice one. Okay, and that's just your link to Big Ideas. So this is the practice that you could print off if you don't have the packet with you. Okay. And then this is the link to Big Ideas, and this is the link to the assignment on Canvas. And that's how each day is going to go. Obviously, I can't put the videos on here until I record, but it still has the notes for 5.1, the practice for 5.1, the link to Big Ideas, and the link to the assignment on Canvas. And those videos will come in as soon as I finish these. So by the time you're in class, the videos will be there. Remember that the assignments are also in the module, okay? They open up as they're opened to you. So Tuesday and Wednesday, the opener is open. I'm recording this video on Tuesday, so you can't see, obviously, the rest, but this will open on January 8th or 7th. It's due on the 8th, okay? So that was just that quick reminder. And then now we'll just get started with our actual lesson. So you do need to have out your Chapter 5 notes packet. And we are going to start with 5.1. Well, today we're doing 5.1. You already did the Chapter 5 opener, which reviewed how to solve equations for a variable, okay, for y. And then also the properties of exponents, okay? The properties of exponents are super important because we're going to deal with that a lot today. So that is something that you'll need to remember some of those rules. All right, so let's get started. Okay, so we are starting 5.1. It's the nth roots and rational exponents notes. This will help you with the 5.4 practice on Big Ideas. And this is going to be video number 1. We're going to be finding the nth roots, okay? So the big essential question for 5.1 is how can you use rational exponents to represent a power involving a radical? Okay, so that'll make a little more sense as we go. So we have, first we need to cover some key vocabulary. Okay, so we have the nth root of a. For an integer n greater than 1, if b to that nth power, okay, that n integer, equals a, then b is the nth root of a. And it is written as n radical a, okay? So it's the nth roots. It can be a square root is the only time we actually don't write the number there. Otherwise, we write a number there. Our next vocabulary term is the index of a radical. So n is that index of the radical, okay? That integer n. All right. So then we need to talk about some core concepts here. So the main thing when we're dealing with the nth root of a, okay, n is a integer greater than 1. Remember that. And a has to be a real number. Okay, so no imaginary numbers there. If n, so if you're taking an odd root, or I'm sorry, an even root, and a is greater than 0, so it's a positive number, or I'm sorry, less than 0, so it's a negative number, you cannot have an nth root, okay? Can't take a square root or a fourth root or a sixth root of a negative number. Okay, that's where we get that imaginary number from. So we'll have no real roots. Okay, but if you're taking the nth root and n is even and a is 0, then you're going to have one real root, and that root is going to be 0. The root of 0 is 0. And that rule actually goes for when n is odd as well. Okay, if you're taking an even root of a positive number, you're going to have two real roots. It's the plus and minus of the nth root of a, okay? And it can be written as both ways. Nth root of a can also be written as a to the 1 over n power, okay? So if you have a fraction that is, or a power that is a fraction that is 1 over n, then that's the same thing as saying it's the root n, okay? Now, if n is an odd integer, so you're taking an odd root like a cube root or a fifth root or whatever, and a is negative, you're going to have one real root, okay? And it's going to be a negative number. I already talked about if it's 0, always a nth root of 0 is 0. If it's greater than 0, so it's a positive number, you're still only going to have one real root, and it is going to be a positive root, okay? Now, the next thing we need to talk about are rational exponents, okay? So if a is 1 over n, so if a to 1 over n power is the nth root of a, whenever it's a fraction, that denominator is the root, the top number is the power. So if we look here, we have a to the m over n power. M is the power and n is the root, okay? It has more exact terminology than that, but that's how we've always written things, is like, so that top number m is just a to the m power, okay? And then when you have it divided by n, that means that's the root. Now you can write it either way, okay? And then just don't forget, if your power is negative, that just means it turns into a fraction, so it's 1 over. That's how you get rid of the negative powers. That was from our rules that we went over in the chapter 5 opener, okay? If you have a negative power, it moves it from the numerator to the denominator, or vice versa, moves it from the denominator to the numerator, whatever, to get rid of the negative power. All right, so let's actually get started here. So we want to find the nth roots, and I'm going to start with number 1. Okay, so we need to find the indicated nth roots of a, root or roots, okay? So in this case, n is 3 and a is negative 216. So that is the third root. Remember, it's the nth root, so 3 is the root of negative 216. Okay, so we need to remember our rules here. N is odd, so we're in this column here. A is less than 0, so I'm going to have one nth root, okay? All right. well, I'm sorry, one nth root, one real root. Okay, so this can be written just like this, and you can get an answer. Or you can write it as negative 216 to the 1/3 power. Answer will still be the same, okay? And the way I like to look at this is, since this is a power or a root of 3, what cubed to the 3rd power gives me negative 216, okay? So you would think of, okay, so something cubed is going to equal a negative 216. That's how we want to look at that. And we need to kind of figure out what that is. So if you can do it in your head, that's awesome. Do that. If you can't, your calculator can do it for you because they're really smart, okay? Now this one's pretty easy. I can do this one in my head, but because I had to memorize when I was in school all the powers of, any number like 1 through 7, I think. And it was so hard. But anyways, I'm not going to make you do that. So you got these lovely calculators. So if you go now on here, we have a square root, but this is not a square root. It's a 3rd root. Well, if you go to math, you happen to have a 3rd root. Go to that math menu. 3rd root is number 4. See, it gives me that 3rd root now, and I can just type in negative 216. And it's negative 6. So this is negative 6. This is the exact same thing, so it'll also be negative 6, but if you don't believe me, you can type in your calculator, negative 216. You put it in parentheses, so it also takes the negative to the power, and you go to the power of 1/3. It's also negative 6. Better be, because they were supposed to be equivalent, right? So your answer here is negative 6. So that means if I were to take negative 6 and I cube it, I get negative 216, okay? So that's a way to think of this, is I'm trying to figure out what this equals. So what to, if I ignore the root here, what to that power gives me that number, okay? And that was negative 6. All right, let's go on to number 2. Okay, now this time I have the 4th root of 81. Okay, again, you can also write that as 81 to the 1/4 power, but I usually just leave them like this. Okay, so I go back to my rules here. N is even this time, and A is greater than 0. Okay, so I'm going to have 2 roots. It's going to be the positive and negative of this. Okay, so I need to put that plus and minus out there. Okay, all right. So what times itself 4 times, because if I take it to the 4th power, it would equal 81. So something to the 4th power equals 81. Now, if you can do that in your head, that's great. I know the square root of 81 is 9. And then I can take the square root of 9 and get 3. And those 2 square roots together is 4 roots. So I know my answer should be, plus and minus 3. Okay. Again, this time the calculator is a little different. If you do the 4th root, you have a square root, the math menu has a cube root, but if you want roots that are bigger than that, you need to type the number first. So I want the 4th root, so I'm gonna push 4, and I go to math. Number 5 has an X root. That means whatever number I typed in is gonna become that root, so number 5. So now I have a 4th root. Some calculators don't put it up there. It'll just have it written in front, but that's okay. As long as you use that math menu, it'll work. And I'm doing this of 81. Now, it only gives me the positive number. You have to remember the rules from this, okay? And really, the only time you have 2 of them is when you have an even root of a positive number, okay? All right, so because 3 to the 4th power is 81, negative 3 to the 4th power is also 81. And that's why we get the plus and minus. Okay, all right, so now you can go to the practice and do problems number 2, 4, 7, 8, and 9. All right, so this is still 5.1. We are doing the nth roots of rational exponents, and this is for 5.1 in Big Ideas, and this is video number 2. We're now going to be evaluating expressions with radical exponents. Okay, so that's what we're doing. And we'll start on the notes number 3. Okay, so this time I have 16 to the 3/2 power, and we talked about those rules in the video, in the first part of the video, where if we have a number to a fraction power, the top number is the power, the bottom number is the root. Okay, so I can write this as 16 cubed as the power, and that can be taken to the square root. Square root is the only one we don't write the 2 there. I mean, you can, it doesn't hurt anything, but you don't need to. All right, so you can write it like this. The problem with this is we always work in and on the inside and work our way out, and we end up with a really big number that we then have to take a square root of. We can also write it as the root first, so I could say the root of 16, and that is to the 3rd power. Okay, this gives us a nice small number that we can deal with and then take it to the power, so it's a lot easier to do without a calculator, much faster without a calculator, okay? So this can be written either way. So let's do this way first, because like I'm gonna usually do them just this way, but I will show you this way and how it's not as easy as this way. Okay, so root first, then power. That's what we like to do. And the root's the bottom number, top number is the power. All right, square root of 16. Here, let me switch colors here. Square root of 16 is 4. And I'm going to take 4 to the 3rd power. See how that was? Square root is pretty easy. Without a calculator, you get a nice small number. All of these that the practice is going to give you and the notes are going to give you, whatever the root is going to give you a small number. It's going to give you 2, 3, 4, 5, 6, maybe 7, or 10. 10's very easy to see, but it doesn't give you hard numbers to get to. All right, and then we want the 3rd power. We want to take 4 times itself 3 times. Okay, and then that is 64. Okay, if you can't remember that, you do have a calculator. I would like you to see you do these without a calculator, though. The only thing is, if I write it this way, I need my calculator. Because you work on the inside first, like we did here. We worked on the inside and got the 4. If I work on the inside here, I don't know what 16 cubed is. 16 times 16 times 16. It would take me a while to do that. I'd actually have to probably do it on paper there. So I'm just going to use the calculator. 16 cubed is, I'm going to equal this one going down here. So this one is still the square root, but the inside turned into 4,096. Now I don't know the square root of 4,096 off the top of my head. So again, I'd have to use that calculator. Square root of that answer, and I get 64. I mean, you should get the same thing because that is the answer. But this way, I have to use the calculator, or it's going to take me a really long time. This way is very fast and quick without the calculator. Okay? So, when we go to the next problem, number 4, I'm going to write it only in the way that's fast and without the calculator. Okay? So, I have a negative out front, and that is not a negative, well, it is a negative 3 power, but we deal with that negative by itself. That negative just means that this is 1 over 32 to the 3/5 power, okay? Remember the negative, if it's in the numerator, we move it to the denominator. If it's in the denominator, we move it to the numerator and just get rid of the negative. The rest of the power stays the same. And now I need to deal with this. All right, so I'm going to write this as the root first, and it is the 5th root of 32, and this marker is kind of blending, sorry about that. And then it's taken to the 3rd power. The top number is the power. Okay, the 5th root of 32, so what times itself 5 times is 32, and that is 2.
and it is still cubed. And 2 times 2 times 2 is 8. So, oh, but I missed the 1 over. I am so sorry. It's 1 over 8. Get all of that in there. Sorry, 1 over 8. I just started solving the bottom. Can't forget the 1 on top. All right, so now you can go to the practice and do problems number 11, 14, 15, 18, and 21 through 24. All right, 5.1, video number 3. This time we're going to be making some mathematical connections by solving some volume problems. Okay? So, in number 5, it has a volume of a cube, and that volume is 1,728 cubic inches. What are the dimensions of the cube? So you have to know the volume formula for a cube. Okay, so the volume of a cube is side cubed. All the sides are the same on a cube. Remember, it makes a block, okay? Everything's the same. And so it's side cubed, okay? And I know that S cubed equals 1,728. So I'm just going to set those equal. And I need to solve. I want to solve for S. What are the dimensions of the cube? I want to know that side link. Okay, S is being cubed, and the opposite of a power is the root. So I'm going to take the cube root of both sides. If I do that, the root on this left side, I'm kind of ignoring that. I wrote the formula here. The root and the power cancel each other out and leaves me with S. And I need the third root of 1,728. I don't know that off the top of my head. So again, I'm going to my calculator. The math menu has that cube root. So number 4 gives me the cube root, 1,728. And it tells me it's 12. So my sides are 12 inches. All right, so the other ones you need to know for your practice, there are a couple of other volume formulas you need. Okay, and so you're going to have, you might want to write these down in your notes so you have them for your practice. Okay, you have a sphere in the practice, and that volume formula is 4/3 pi r cubed. Okay, so if it gives you the volume, you plug that in here. To solve for r, you'll divide by all of this, by the 4/3 pi, leave it in parentheses when you divide, and then you take the cube root. And then you'll also have a cylinder. Okay, and that volume formula is pi r squared times h. H is the height. Okay? And again, if it gives you the volume and you want to get r by itself before you can take a square root, you're going to divide by whatever the height is and pi. Just put them in parentheses and divide, and then take a square root. All right, so now you can go to your practice and do the 2 volume formulas I just gave you the formulas for, number 33 and 34. All right, this is the 4th and final video for 5.1. Now we're going to be solving equations using the nth root. Okay? So, those are our instructions. I'll just leave those there. Find the real solution or solutions of the equation. Round your answer to 2 decimal places when that is needed. Okay? So number 6 in the notes, okay, is 4 times x to the 5th equals 128. Okay, so here we have to get whatever's to the power by itself first. So I need to get x to the 5th by itself. To do that, I need to divide by that 4. So I end up with x to the 5th equals 100 and, oh, no, it doesn't equal 128. I'm just kidding. 128 divided by 4 is 32. Okay? And then I need to solve for x. So to get rid of the power, that's where we take that root of both sides. So I want the 5th root and the 5th root. And then the power and the root cancel and leaves me with x. So I end up with x equals the 5th root of 32. So if you can think of what times itself 5 times is 32, you can get that answer. Otherwise, use your calculator. The 5th root, you'd push the 5 first, then you go to math. Number 5 is that x root, so it gives me that 5th root of 32. Okay? Now, these ones need to still go by the rules of if it's that we learned in the first video, okay? If it's an even root, you might have 2 answers, okay? In this case, it was an odd root, so I didn't need to worry about that. So you do need to pay attention for that. All right, so that was number 6. Number 7. All right, now I have everything to the power is all by itself. I have everything on this side is to the 4th power, and on that side is a constant. So I need to get rid of the 4th power first. So to do that, again, we're going to take the 4th root of both sides. Okay? That makes it messy, but this ends up leaving me with an x minus 3 equals, and it leaves me with the 4th root of 21. Now this is where those rules come into place. It is an even root, and it's greater than, and a is greater than 0, okay, because 21 is positive. So I know I'm going to have 2, so I actually need to put plus and minus right there. Okay? That's the hardest thing to remember because this is the only time it's when it's an even root and a is greater than 0 that you have that plus minus, and you just have to memorize that, okay? So, I'm pretty sure I'm going to get a decimal here. Actually, I know for a fact I'm going to get a decimal there. So I'm going to go ahead and just add the 3 to both sides so I can get x by itself and leave it at that. So I end up with x equals 3 plus and minus 4 square root of 21. Okay? So I'm going to get 2 answers here. I'm going to get where I have the plus, and I'm going to get where I have the minus. Okay? So I'm going to use the calculator because the 4th root of 21 is a decimal. Okay? There's no other way to do it, so I'm going to put the calculator over here. Okay? So I'm going to have a 3, and I'm doing the plus first. So plus the 4th root. So I push 4, math, and I don't know why I wrote 4 so big. This is the root. It's not like 4 times that, okay? Number 5, so it gives me that 4th root of 21. Now this says round to the 100th place, so 2 decimal places there. So it'll be 5.14. Okay, that's one answer. And now I need to do the minus. So I'm going to go 3 minus that 4th root of 21. And I get 0.86. Make sure to round correctly because the next number was a 9, so I had to round that one up. All right, so that was number 7. Number 8. I need to get whatever is to the power all by itself. In that case, it's x to the 5th. So I need to move the 21 first. So I'm going to add 21 to both sides. So I get x to the 5th equals a negative 43. Okay, we need to get rid of that power of 5. So I'm going to take the 5th root of both sides. And then that gives me x equals the 5th root of negative 43. Now, this is an odd power, so I don't have to worry about having 2 answers. And it is a negative in the root, and I can do that. It's okay. So I want the 5th root and negative 43. Oops, and I put plus 43, didn't I? Let's just go back. These nice calculators just let you change, and that's negative. Gotta use negative, not minus. Sorry. And gives me my answer, and I rounded 2 decimal places. So this is approximately negative 2.12. Okay, that was number 8. Number 9. 9 and the final problem here. All right, so I look at what's being taken to a power, so x cubed here. I need to get that all by itself, so I've got to move some things first. You always start farther away, so we're going to subtract the 100 first. So I get negative 1 over 10 times x cubed will equal a negative 100. Now I need to get rid of this negative 1 over 10. And I'm going to do that by multiplying both sides by a negative 10. It's a reciprocal, you know, you flip the fraction. Okay? So these would have canceled, leaves me with x cubed. Negative 100 times negative 10 is 1,000. Now I need to get rid of the power. So I need to take the cube root of both sides. And when I do that, I end up with x equals, and the cube root of 1,000 is 10. If you can't remember that, you can use your calculator. Okay? All right, so now go to your practice and finish it up by doing 36, 37, 41, and 42, and then submitting it to Big Ideas. Take your screenshot, turn your screenshot into a PDF, and turn it into Canvas.